So hello all, welcome. This is second lecture on astronomy and science. We are in uh, we're going through the numbers in astronomy. Last lecture, I introduced you to light year. Light year is used for measuring large distances. As you see, when we are talking about astronomy, uh, the objects, the celestial bodies in the sky are so far apart, the kilometer or meters or yard does not make sense. Like, for example, the nearest star, the Alpha Centauri system, Alpha Centauri, Proxima Centauri, this is Alpha Centauri A, Alpha Centauri B, they are about 40 and this many zeros, or 40 trillion kilometers. So instead of saying that 40 trillion kilometers, we redefine the distance in terms of light year. Light year is the distance traveled by light in 1 year time. So instead of saying all these numbers here, it's more manageable to say 4.3 light years away. So our next nearest star is 4.3 light years. It's still quite hard to comprehend that distance, but the number is more manageable. And also, when we talk, the distance within the solar system, and light years may be too big a number to define the distance, or to put distance in terms of light years. So we use AU, the astronomical unit. The the Sun Earth distance, the distance from Sun to Earth is defined as 1 AU, or 1 astronomical unit. In terms of light year, it takes about 8 minutes 20 seconds for the light to get, so it would be 8 minutes, 8 light minute. um, and so instead of that, we use AU, and like I said, the AU is distance from Sun to Earth, and in terms of kilometers, it's 150 million kilometers. And for Mars, that would be 1.5 AU. And so that's a standard reference, um, the distance between Earth and Sun. So that's like 1 AU. And Mars is a little farther away, so that's 1.5 AU from the Sun. And Neptune is 30 AU. Um, and so, like, for example, it's much easier to comprehend 1 mile. So this is analogy, the example. Um, you, instead of saying 5,280 feet, or even 63,360 inches, it's easy to understand. And also, the numbers are manageable when you just say 1 mile. And so, depending on what if we are within solar systems, we will measure distances in terms of AU. When we are outside the solar system and we're talking distances to stars, galaxies, constellations, clusters, supernova, black hole, whatever celestial bodies out there, farther out from the solar system, we will be using light years. And it is very, uh, uh, helpful if we understand, the distance in terms of light years. If we can comprehend, that will really help us to uh, really have that feeling of distances, uh, of two distances of all these these celestial bodies out there. And so in terms of so light travel time, light does not travel infinitely fast, meaning light, we know light is the fastest thing uh, in the universe, yet it has a finite speed. And so that finite speed means, it takes certain time for the light to reach from point A to point B. Like I said, the light from the sun takes about 8.5 minutes to get to Earth. The nearest uh, uh, star, Alpha Centauri, it takes 4.3 years to get to us. The Andromeda Galaxy takes about 2.5 million years, 2.5 million years for the light to get to us from Andromeda. And this has a consequence. Okay. Remember last lecture I said is we are when we are seeing objects in the sky, we are actually looking in the past. We are looking at the history, meaning, if it takes 8.5 minutes for the light from the sun to get to us, so that means 8.5 minutes have already passed in the sun. So we're seeing sun as it was 8.5 minutes ago. So at this instant, let's say if sun were to disappear, just vanish at this instant, we would still see the sun for next 8.5 minutes, 8 minutes 20 seconds, because that's how long the light would, the last light that left the surface of the sun would reach us, and after that it would vanish. And it makes more sense if you look farther out objects. So Alpha Centauri, the nearest star that we see, the light has traveled for 4.3 years. So for the last 4 years, the light has been traveling. And tonight, if you go out and if you see Alpha Centauri, that means the light you see is 4.3 years old. So we don't know what happened in the last 4 years. The star may have completely vanished. It has gone somewhere, supernova, exploded, whatnot, in the last 4 years, but we would not know that. And same thing with the Andromeda Galaxy, 2.5 million years ago. And Andromeda Galaxy, we'll talk about a lot because this is the nearest galaxy from the Milky Way Galaxy, not the stars, the cluster of the stars, which we call galaxy. And so, here is a short video on light year. So what does it mean to say, things are at certain light years away? And I hope this will help you comprehend the distance of the, nearby astronomical objects. Let's watch it. This is our galaxy, Milky Way Galaxy, and this is about 100,000 light years in diameter. This is measured. Our solar system is one of the arms. You see there are arms coming out of this spiral galaxy here. This is the center of the galaxy, and all the stars are distributed around, and also it forms these spiral arms around it. This is one arm, this is another arm, this is the Perseus arm, and we'll look into detail of the about the galaxy, Milky Way galaxy later. But our solar system is somewhere here at the edge, towards the edge of the galaxy, and this distance, the diameter is about 100,000 light years. And so now you see it makes sense um, uh, to measure these large distances in terms of light years. So more, let's take the tour of the universe. Uh, and I mean, we looked at how big a solar system is. Now we can make a sense of it. The solar system. We also zoomed out of the solar system and saw the nearby stars, and even we looked at the whole galaxy. Okay, but galaxy is about 100,000 light years in diameter. Is that big? Uh, but we have to understand that our galaxy, Milky Way, is one out of about 400 billion other galaxies in the universe. So universe constitutes of everything. And so, we also need to comprehend that size going outward from solar system to Milky Way and add 400 billion other galaxies around forming the universe. And let's start with the two nearest or one nearest object to the Earth, and that is the Moon. Here, the beauty of this picture here is this is to scale for both size and distance. This distance and the size of the Earth and Moon, when you draw it to scale, that's how they look. And this is to scale the solar system. Uh, the Jupiter here, Earth, um, and the Sun itself. And as you can see, that Sun is quite large compared to any other objects in the solar system. As a matter of fact, if we're to look at the mass distribution, the Sun has 99.9% of the mass, and only about 0.1% is rest of all the planets, asteroid belts, the dwarf planets. Um, so that tells us the size of the Sun, compared to rest of the planets. And this is our solar family. As you see, there are 8 planets. There are a lot of dwarf planets. Ceres is within the asteroid belt of Mars and Jupiter. Ceres, we started calling it asteroid when it was first found, but it is only 9 times smaller than the Pluto, and we call it dwarf planets. There are many other dwarf planets within this solar system, and this is one of the reasons that Pluto was demoted from the planet, because if we call Pluto a planet, there are other candidates here, because there are some more than this that would require to be called planets. And so the Pluto was demoted, and there are other reasons. Pluto was demoted, and we redefined, we set a definition, okay, for what object we would call a planet. And that definition did not fit uh, for Pluto to be called planet. Okay, and those definitions have certain criteria, and we'll talk about it when we look details about uh, uh, when we study in detail of the inner planets, the rocky planets, and the outer planets as gas giants. And the other ones, if you go out of the solar system, again, this is Andromeda Galaxy, also called M31. It is a spiral galaxy. Uh, there are types of galaxies, and so the most abundant, the most common ones are the spiral ones, and very similar to Milky Way Galaxy. And this is 2.5 million light years away from us. And a fun fact, the Milky Way Galaxy and the Andromeda Galaxy are in the collision course. So they are headed towards each other. And in about 4 or 5 billion years from now, it is expected that both of these two galaxies will collide with each other, or they will pass through each other. The collision means, that the distance between the stars are so far apart. I mean, sun and our nearest other sun is what, 4.3 light years away out the center. So there's a vast gap between the stars within these galaxies. And so even when we say these two galaxies like Andromeda and Milky Way, they collide with each other, the stars may not just bang onto each other, but they may pass, and the gravitational field will, when they pass and they have the momentum, they will pass each other, but the gravity will attract them back to Earth, and they will spiral together. I'll show you what happens, when that such collision happens when we get to the galaxy. And the next big things in the universe are star cluster itself. I mean, galaxies are star clusters, but this is this one cluster, not a spiral, called M9, and this has relatively less number of stars, 250 stars. So for example, in our galaxy, there are billions of stars in our galaxy, and this is a cluster that has only 250,000 stars, and this is about 25,000 light years away. And here are all the galaxies. So here all these dots are stars, but here these dots, everything here are galaxies, and this is a cluster of galaxies about 60 million light years away in the constellation of Fornax. And there are, and this only these are like a few hundreds, thousand here. And when we talk about the universe itself, it, it's estimated to have, the higher number is 400 billion galaxies in the universe. So that means, that we also need to comprehend now the size of the universe, not just the size of the planet or size of our solar system, or not just the size of our home galaxy, Milky Way Galaxy, but that's everything out there. And for that, we have this data compiled together of the visible universe, and this is based on the stars or the galaxies that have been mapped so far. It's like mapping our states, our country. It's like mapping the whole universe using powerful space telescopes and ground telescopes. And let's see, and let's try to comprehend. Let's take the tour of the whole universe. I wanted to pause here. This is the center, that's where the Earth is, and Earth has only one natural satellite, the Moon. It's a celestial body, and earlier at the beginning of the video, you saw all these artificial satellites. So any object that orbit a planet are called satellites, and if man-made artificial objects are set to orbit, those are artificial satellite. All our GPS satellites, television, internet, weather, those are artificial satellites. And as you saw, there's green line surrounding the Earth. There are actually thousands of these satellites from different countries around the world orbiting the Earth. And the Moon is the farthest one, and it's a natural satellite. And so the recent news you might have heard, the JWST, James Webb Space Telescope, the largest space telescope that mankind has launched, it has finally reached its destination, and the sun is up here in that direction. The sun is that there. This is Earth, and behind the sun, so behind the Earth and Moon, here there's a point called a Lagrange point. Um, uh, uh, and that JWST is said to orbit this Lagrange point out here, facing away from the sun. It's shielding itself from the sunlight, and uh, as Earth rotates, and it will go along the Earth every time. Its back is facing toward the sun. It's shielding all the sunlight and mapping the universe, or observing planets, moons, stars out there. And that's where the JWST is located, 1 million miles from Earth. Okay, and so to close this chapter, um, the charting of the cosmic time, um, this this is our cosmic calendar. Let's we assume that, or let's say the universe, everything started uh, uh, in January. So Big Bang occurs in January. Uh, Big Bang is when everything in the universe came into life, let's say. And we'll get to that chapter later. But this is to give you a bigger picture, the timeline of from the birth of the universe until now. Okay, and we assume that the Big Bang started on January 1st, or and on February, and it evolved through all these months. Okay, initially it was all energy. Energy, gets converted into mass. Uh, the first elements are formed, like hydrogen and helium, and these hydrogen and helium elements start to form these clouds together, and these clouds, under gravitational, uh, compressions, they start to form stars, and these stars form star clusters and galaxies. And in May, so after 5 months after the Big Bang, our galaxy Milky Way has formed. So it took 5 months. And in June, more stars form, more galaxies form, and so June, July, August, planet started to form um, uh, uh, around these stars, even around our sun. The planets started to form, and on September, 9 months after the Big Bang, our solar system forms and life on Earth begins. Life, the microorganisms start to begin. September, October, Earth's atmosphere becomes oxygenated. So we have oxygen in our atmosphere. And with that, October, November, this is the 11th month of the year, first complex life form appear, like plants and tiny creatures. And that's November. Okay, and we have more detailed news about the December. So December, uh, that's December calendar here, day by day, 1, 2, 3, 4, 7, 18. So all these first 18 days, the evolution of this complex life form, grows, and that these smaller life forms, evolves into bigger ones. And on December 19th, first vertebrates, animals appear, and land plants appear on December 20th. First plants on land, they were all in the water before. And December 21, 2020, 24, and December 25, dinosaur appear. First mammal appear on December 26th. And the timeline wise, the dinosaurs were here, ruled the earth. I shouldn't say ruled. They walked on the surface of the earth. They lived on earth 65 million years ago. Okay. And that's when first mammal appeared. But sadly, on December 30, there was a big asteroid that hit the Earth, and everything was almost extinct, including dinosaurs. December 30. Okay, and that's like 65 million years ago, and we waited another almost 65 million years, and that's December 30, the last day of our calendar year, that human appear. And the year-wise, the Homo sapiens, or humans, appear on Earth around 100,000 years ago from today. It's only been 100,000 years that first Homo sapiens, lived on the surface of the Earth, and the evolution of the Homo sapiens, um, um, the eventually evolved to become the modern day human, and we are still living in December 31. So this is our cosmic calendar.